Hello everyone, this is Akansh Suman here. Now we are going to discuss the next topic, number of instantaneous center in a mechanisms. I already told you about the instantaneous center. Instantaneous center means the center which is defined at an instant only. Okay, every instant, every instant, the center is going to be changed, and that is for general motions. When the body is in general motions means it is a combination of the rotation and the translation. So when the body is in general motion, the instantaneous center of rotations is not going to be fixed. It is always keep on changing. So in order to find out the angular velocity for the body which is in general motions, we have to consider the instantaneous center. So when we calculate the angular velocity for the general motions body, that would be the instantaneous center. Okay. Now we have to calculate the number of instantaneous center for a body, or you can say for a mechanisms. So first we need to understand what is the mechanisms. I already told you in the simple mechanisms. How can we say the mechanisms? What is the criteria for the mechanisms? The criteria is that we can say if there is a chain means what? Chain means the first link is connected to the last link. Okay. The criteria for the chain to be considered as a kinematic chain is that they are having relative motions with respect to each other. That means the number of links which are making the chain, they are having the relative motions with respect to each other, but the relative motions should be in constant nature. The motion should be constant. Then we can say the chain as the kinematic chain. Kinematic chain. Okay. So how can we get the mechanisms from the kinematic chain? One link must be fixed. One link must be fixed. If you have fixed any of the link in the kinematic chain, you will get the mechanisms. Are you getting my point? So criteria is that one link must be fixed for the kinematic chain to be considered as the mechanisms. And when you give some input to the mechanisms and you will get the some output, then you can say this is the machine. Okay. So this was the basic definitions for the mechanisms. Now come to the topic, number of instantaneous center. There is a formula. If there is a number of link in the mechanisms, I am going to write here that if there are a number of link in the mechanisms, it is denoted by L, and we have to find out the number of instantaneous center. Number of instantaneous center. How can we find out? It would be N is equal to L minus 1 by 2. So this is the formula to find out the number of instantaneous center in any mechanisms. So for example, if I say in the mechanisms there are the number of links which is equal to 4, that means 4 bar chain, you can say in the 4 bar chain there are 4 links. So how many number of instantaneous will be there? So number of instantaneous center, number of instantaneous that would be equal to 4 into, that is 4 into 4 minus 1 by 2. You can calculate using this formula, and that would be 6. Okay. If there are a number of links that is equal to 5, that means if there are 5 links in any mechanisms, so how many number of instantaneous center will be there? That is 5 into 5 minus 1 by 2, that means 10. Are you getting my point? If there are 6 number of links in any mechanisms, you can calculate also the number of instantaneous center. Basically, numerical question is going to be asked in the objective. Okay, engineering service examination prelims, they can ask you to find out the number of instantaneous center in any mechanisms. They will give you the number of links. You just have to use the formula and you got the answer. So that is 6 minus 1 upon 2, that is 15. So like that you can calculate the number of links, number of instantaneous center. They will give you the number of link. Okay. Now I'm going to tell you that what type of instantaneous center would be there. Okay. We all know that instantaneous center is denoted by I. Okay. So we have considering this. Number of instantaneous center is 10. Now we will see the instantaneous center type. That would be I. I'm going to show you here that for L is equal to 5, the number of instantaneous center, that is 5 minus 1 by 2, that's equal to 10. Now we will see. First instantaneous center would be I12. We will see all of the 10 instantaneous center. I12, I23, because basically I12, I23 is basically defined for the relative motions between link to 1 and the link 2. I already told you in the previous video. Okay. Instantaneous center is defined for the relative motions. That means I12 is the center of rotation, center of relative motions between the link 1 and the link 2. I23 is the center of relative motion, center of rotation of the relative motions between link 2 and link 3, and I12, I23, I34, or you can consider it in a simple way. Okay, it would be somewhat difficult, so I'm going to consider like that, so it would be easy to understand. I12, 13, I14, 15. Okay, because there are a number of links that is equal to 5, so we will stop like at there. Now next would be I23. Okay, don't write I21, because I12 and I21 both are same, because I12 or I21 both are same, because I is nothing but the center of relative motions between link 1 and the link 2. So whenever there is a relative motion between link 1, link 2, it can be defined as I12 or I21. Both is same. So I23, that is I24, I25. Okay, next would be I34, I35, and the finally would be I45. So you can count here. There are a number of instantaneous center. When you calculate all these, you will get the 10. So that is 4, 3, 7, and this is 3. Finally, the number of links, that is equal to 10. So this is just the representation of the instantaneous center. You just have to know how can we denote the instantaneous center in mathematical form. So that's why I'm going to show you here by considering link is equal to 5. So here you can calculate the number of links, number of instantaneous center. We will see the numerical problems based on the instantaneous center further. Okay, we will see, and we will use I123, I23, and I34, 35, like that. All things we will consider in the numerical problem, so it would be easy to understand how can we use the instantaneous center in the numerical problems. Okay, so I hope you will get the, and I hope you will understand this concept.